Welcome, Michael here. We're going to look at Euclid's Elements of Geometry, 13 books. I'm not sure how far we'll end up getting, but I think we'll use Grasshopper 2 with a little bit of Grasshopper 1. We'll take a look at the elements in Book 1, the fundamentals of plane geometry involving straight lines, and we will just translate from a translation of the Greek into Rhino. So let's just take a look at what we get right off the bat. Pretty simple stuff for those beginning Grasshopper or Grasshopper 2. So I think this is how I will teach it, and people can jump as far in as they want. So the first one, point is that which has no parts. So basically, how do you construct a point? You go up the vector, you grab yourself the point, you pull it in. Then book 2 is the line, is the breadths, that's an interesting word, length. So as you change that length, and we take a look at that line, you have to find out where that is down here. It's been covered up by a few other geometries, but I've grabbed that 2 points. I've just taken this point and the other point and produced the line in between it. Now, one thing you can do on here is you can go into data and metas and grab things like display width, for instance, and you could grab that geometry and then you could provide a width to that. Now it started at 0. Chances are you're going to have to jack this up to something in the scale diagram, something like 10, and then if I put that in, I should be able to get a width of a line, and there it is. So you start to see it just to gain some control. And there's the line from there to there, and that's built between those 2 points. And you can always do a fast color coding if you like that. But I'm not actually going to leave those visible on. I'll probably translate this one down as we go just to see what we're writing. Number 3, the extremities of a line are points. So you just grab this point and this point. But for that, you'd have to go into here, and you wouldn't use the width of a line as a meta. You would go in and grab the data metas, probably display radius of the size of points preview. So let's grab this one. Hopefully we don't crash out. Let's grab that point, which is there. And let's slide through the same type of number slider, bring it down here. And these really do crash quite a bit, so you have to be careful with it. So as I get into here and grab, you can see that one's going to 10, but you can see how relative to the size and scales of things, you may want to up them a little bit. So you can see that X, and what's nice is you can actually have different types of sources and points on here. You can actually change those to the metas, but I'll just leave the X for now. So I'm going to take that one and put that one invisible as well. And that will show you that there's 2 points at the end of each line. And then the definition for it, pretty simple. A straight line is a line which lies evenly on the points itself. So what I did was just divided the points, and there they are. I'd taken that original line and then divided the points along there, and you could always grab that as a means to visualize those points as well. And hopefully I don't crash out. I've taken my number down. I'll just have to make that one big. These are the points, and they should be going in, but this might be a sign display. There can always be something that goes wrong in here. There seems to be a lot of bugs. I'm not sure if I've caught it here. Maybe if I graphed it. Now, I'm just thinking like why from this one to that. Oh, design display radius. That should be fine. This one was working fine as a point, probably because it was a single point. But once again, it's kind of, oh, what am I doing? I took it off the hidden. Oh, sometimes I'm just totally foolish. So let's take those points and pop them in there, and there you could go. You can see all your points, and they're all along that line. So there they are. We'll just keep using these as we go. Maybe I will leave it on so I don't make the mistakes, and we'll keep sliding our meta visuals down as we go. So we can think to use those to make points and curves visible in case we can't see them in our model. So let's just keep going. The next one, definition 5 in book 1, is the surface of that which has a length and breadth only. So I took one curve and I just moved that curve up to the other side, and I did a loft from curves in between it, which I could change that color to blue. And I think we'd end up seeing it if I left it. Let me see what I'm on shaded. I think it's being overrun, that surface, so it's not actually taking on that color. Not sure if I have my visibility off. It's just the nature of some of these things when you're working them. They just choose what to go to. I'm not sure why that surface is not. It's enabled. It's visible. It should be going blue, but it probably, because the surface has been used again later, that's overriding that color. So I'm just going to guess at that, take this one to enable. And then why isn't this one coming up? visible or not. Well, that's interesting. I'm just a little curious with that. Sometimes you have to rerun the script to do it. There you go. You kind of see the blue is coincident with another one. So um, we'll just have to deal with it. Let me jump in here and make that one enabled again. But the colors can be tricky without adding a meta, so you might want to find a meta for a surface. But needless to say, we're just proving that the surface is that which has a length and breadth only, because that's actually all that has. It has no volume at all. Then we'll keep going. We're just going to take a look at the first top 10. The extremities of the surface are lined, so you can use the old deep rep to get at the curves on the edges. And if you want to see those curves, you can kind of visualize those by coming down here. And hopefully those curves will slide pretty nicely into our curve tool and with no problems. Now those are our points. That's my display radius. The side width. Well, it's okay on the points. Enable this one. Got to make visible. There you go. There's your edges. So just kind of keep it up and running. I guess we'll leave both on visible and enabled so we can see everything. All right. The next one, 7, is the plane of a surface is any one which lies evenly on the straight lines of itself. So what I did was I did a subdivide. Actually, what I did first was just use an iso trim, which was nice and took those edges. So let's overpower those edges, make those the visible ones. Like I said, if you get into too many of these, you can really have trouble. So let's jump in there. There are the edges of the iso trims, just to kind of say, as an iso trim tool, that's really not the one you have to do. It's evenly spaced, and then I use the divide to domain to do that, just to get these little microplanes that I can check the edges. But you don't really need that one. You can go in here and just grab these curves, which are very nice throughout here. I'll grab the U and V and slide them into here, and I'll probably want to get my that out of the way for a while, that just out of the way. We'll end up dealing with that in a minute. Got two lengths of line, but let's just grab the U and V just to show where they are. There's the U and there's the V. And those lay on the line, so that's kind of a little more adequate. You can position that wherever you want and move these around as you go, and you can always, I believe on the meta, plug in both. Yes, and now you can actually play around with these slides. What's interesting is the U actually moves outside of the domain past it, double that size, because I iso trimmed it shorter. I think there's a default in here. Well, and I can also change the point count if I wanted to do that. So those two means are kind of a way in Grasshopper to take a look at definition 7. 8 is, and the plane angle is the inclination of the lines to one another when two lines in a plane meet one another, and they're not lying in a straight line. You can't just have a line parallel with the other one and lined up to the other one. So if they are off, we can measure all of these angles around here. You'll see it works at the 1/2 pi, which is 90 degrees. Now, if you import that number into a text tag and put it in here through curves, I think it's text actually, create, and you want to put a curve, you find a curve to put that text, and if you end up putting that text in, you'll find that text actually reads as pi instead of in here in a line to a certain volume. But I'm not going to mess with that because I bug out every time I use that node. Anyway, that's another means of doing it, looking at the vectors, just using the old angle from vectors, which is in Grasshopper 1. I think it's in the vector tab over here, and it should be angle. There it is. So it's that tag I was using. Now you have to drag out of here to actually get it to work, so you have to click angle and bring it up from Grasshopper 1. All right, so 9, and when the lines containing the angle are straight, then the angles are called rectilinear, and I proved that just by taking those two angles that came out from points at the same point and produced a very interesting rectangle with it. So these rectangles probably have to be exploded into lines in order to work with one of these visualization tools down here. I can try and put a rectangle in, but I can guarantee you it's probably going to bug out on me. So what I'm going to do is just quickly go down to surfaces, and I'm just catching a lot of stuff happening in here. I'm just going to grab my edges, and it will not deep rep that, obviously, because it's not a boundary representation of anything. It's just the curves. I probably would have to explode, and even then I'm probably getting into curve analysis, divisions. Shatter might work, but it's going to want to account on where that is. Explode, I can never remember. If you can't find something, it kind of stinks in Grasshopper 1 because you have to go down here, you have to type in your explode, and I usually was pretty good at this, but it's been a while. Then you got to go on it with the Control Alt you'll see it's in curves and way over there on the end, one of the most common ones. I can't believe I forgot that. So let's just go up here and grab the explode. And let's see if we can grab that curve and see what it's asking here. Recursive true. I should have 4 planar lines. I should be able to input them. And display radius is for sphere, is for points. So that is not what I want to do. I want to take my explode and put it in here. And there we go. I've exploded my rectangle. I can take a look at that. So nice, and I can still play with where those vectors were connected. I just kind of came off of whatever I was playing with here, so I can change that rectangle. But it kind of proves it's rectilinear because you're playing with that, and I'm just making it meet at a point on one of the corners of the V instead of the U. And you can play with that script if you want. And then the last one, which I thought I had right here, number 10, and we're going to go through all 23. And this is probably the first one that actually doesn't assume too much, but when a straight line standing on another straight line makes an adjacent angle equal to one another, which is like making a 90-degree angle, but they don't talk in 90-degree angles, they talk in perpendicular ones. Each of those equal angles is right, and straight line standing on the other is called perpendicular to that on which it stands. So this little diagram is going in. I've used the number count to make these points. You'll see what I'm doing on a vertical way. And I'm going to just take these little visuals down here so you can see what I've actually created. I'm going to move this angles to prove they're equal. They're both 90 degrees or 1/2 pi. But over here, I can grab this data and I can say, okay, let's just fudge this in here. Let's take this line and override this one. And you can see that's the first vector. And the points are still there causing a lot of problems. So I'm just going to take the visuals off of there. Then I have another line here, which is the other one. And those are made from the straight line. And from these two, I'm creating the vectored angles between probably what would be easiest is if I got rid of this. I know this is kind of clumsy, but I'm giving you the scripts on Patreon, so just jump in here. I'll make one blue, I'll make one red, and I'll make one green. And that way, when I put these out, boom, 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 you can see that we have the blue, and I hope I haven't taken it off visual. Let's take this one over to here. Oops. Still on the other one. There we go. We got a blue, red, and green. And what you're ending up with are angles between it. And this time, you might want to grab one of these lines from this vector and put on the 1/2 pi in this corner and this corner to basically deal with the 10th definition, which is when a straight line standing along another straight line makes the adjacent angle equal to one another. Each of the equal angles is right, and the straight line standing on the other is called the perpendicular to that which it stands. So it's really a definition of a perpendicular. Fun little exercises to do if you want to apply a lot of these and have some good visuals. Then I play EUCLID'S online. I'll put a link somewhere around here to that. But basically, I'm just scripting. I'm going through the definitions, and I'm finding ways of bringing them in the Grasshopper on a very simple geometric manner. And this is only for data visualization of things that we can end up making some pretty cool proofs, like the Pythagorean theorem. Anyway, thanks for watching. Mike at Wickerson Studios, playing around with Euclid's Elements, Book of Elements, Euclid's Elements of Geometry. Thanks for watching.